is we talk about the baseline knowledge. I will not start explain Terraform from scratch, but we also have more, let's have a look at why we're going to do modularization, what is the common sense behind it, and also why it makes sense using modules in Terraform. And also what are the best practices about it, do's and don'ts, because I've seen so many incidents and accidents in code, and sometimes modules are written in a way that it's not really usable or best practices. So we will have a look at this point as well. We're going to have a look at how we're going to publish and version modules the right way, so that it's actually also regarding the lifecycle pretty easy to handle. And also the point number 5, we have a look. There's a lot of additional tooling out there, even for free, which can be implemented to improve your quality of the modules. I can give you some examples about these toolings. And also we're going to have a quick summary Q&A session, and so you can have a look or summary what are the essentials of this talk. So what is the baseline knowledge, what we need? So why are we going to do modularization? How are we going to come from plain code, which I've seen quite often at customer projects, to certain kind of modules, and why is it so essential? If we have a look at a house, which is more or less the hyperscaler or a cloud platform. So if we think, okay, if we see the cloud as like a building, we need a good foundation, yeah, like clear basement, and this basement is more or less the modules. Yeah, the better the modules, the better the basement is as well. And you can have different modules, for example, for DNS, for web applications, for an event hub, for VPN connection, or for key vault, whatever. And you can provide different modules for all of these kind of resources. And these modules can be used in different templates. So for example, if you want to do a rollout of a web application, you can use these modules. If you want to do for example, you want to do a rollout of a landing zone, you will also use other modules, which are also down here. And you can reference these kind of modules. And if you use these templates, more or less, the modules and the templates, you can do the rollout of, for example, an Azure landing zone, or the landing zone can also be on AWS or on Google. And you also can, on top of the landing zone, you can also do the rollout of a web application, of a CRM platform, of an IoT platform, whatever you want. You can also even roll it out with cross-platform, so you're not really focused only on Azure or limited on Azure. You can also put it on AWS or somewhere else. So with Terraform, it's easy to do. And also, I mean, everyone is talking about AI. You can also provision your AI services using this kind of modules. But the thing is, if you have poor modules or poor templates, you will have an issue with this foundation, like you can see it here. For example, if one column breaks, the whole building can flip aside or collapse even totally. Yeah, that's the reason why we said, okay, it makes absolutely sense to have a look why it makes sense, okay, to have nice and clear modules which can be used across or to set up your building and do it the right way. I've seen also quite often at customer projects bad modules. So what happens if you provision your environment with bad modules? It's like in the picture here. After the first change, you will have issues, and sometimes all of a sudden resources in the cloud environment will start to be recreated or will be accidentally deleted. So you can destroy more or less the whole environment pretty easily. And also the technical depth is getting bigger and bigger. That's also the reason why I said, hey, it makes totally sense that you start with nice and clean modules to set up your cloud infrastructure, instead of using bad modules and say, yeah, let's do it later. Yeah, that doesn't make sense in my opinion. That's the reason why we say, okay, from the beginning, start with with modules, have a plan, and think about how you're going to set up a central module library pretty much in detail. We're going to talk about this in the next few slides. So what does modularization means in the language of Terraform? I mean, you can also say with Bicep or with Pulumi, it's pretty much the same, yeah. But how are we going to use modules in Terraform, for example? So a module is like a magic box. Yeah, you have a box where something in this happens, yeah. And if you have, for example, inputs and you have outputs, then you have inputs, which these inputs go into the module, and then something will happen into this box, and then there will be the output. So a lot of Azure resources, for example, like virtual machines or disks and network interface cards or storage accounts will be created on the cloud platform. Yeah. This is more or less, it's not really the magic box, but today we're going to have a look inside this magic box. So how are we going to create or build this box so that it makes sense? Yeah. Instead of using something else or using Azure predefined modules. So we're going to have a look at this magic box. So what is a module in Terraform language? Yeah. So a module, I've seen several definitions here. A module is a container for multiple resources that are used together. Yeah. For example, if you think about a virtual network on Azure, what characterizes a virtual network? So it's not only the virtual network, it's also a resource group, it's the virtual network itself, it's a subnet, it's a NSG, it's a route table, and so on. Yeah. Or a collection of files and folders in a repo. It's also a definition of a module. So we have a look at this today as well. So how we going to have, so what kind of files and folders are in a repo for a Terraform module? And also it is the baseline for producing quality and reusable Terraform code. Yeah. So the definition of its Terraform is also a module in Terraform is the definition of the infrastructure. So it defines the what. Because Terraform is a declarative language instead of an imperative, we don't have to think about how it will be created. It's only about what will be created. So we have to find our resources which will be created inside the module. That's the second part is also super important. It's a module is always independently usable and independently testable. So I've seen quite often modules which are dependent on other modules and on the next modules, and then you have something like a chain and you run into dependency issues. Yeah. But that's the reason why if I program the modules, I like to have it independently usable and independently testable. Yeah. So reusable. A module is reusable across different projects and environments. So that's also the reason why it's recommended do not hard code names or so on, or hard code projects or environment variables into your module. And one module is one module is one repo. So it's a one-by-one relationship. So sometimes I have seen quite often projects where they say, hey, let's put several modules into one repo. Yeah. That's not the case. We have always one module, one repo. Yeah. Why this makes sense, we come to that later in the example if you also have a look at the Terraform cloud. And it's used to encapsulate complex logic, so we don't have to think about what's going on in the module. If we consume it, we just put the parameters in, and then our cloud resources are gonna coming out. And a module is easier to manage, test, and update and consume. So if we have modules, we can easily test them and also update them, and all guys or all departments within an organization can also use it. Yeah, we will also have a look at this kind of library aspect over the next few slides. So what is the current situation in organizations if we have a look on if they use Terraform or Terraform modules or whatever? So for example, we have a governance team. They have governance capabilities like whatever role assignments, role definitions, policies. They're gonna do a rollout, or they also need resource groups, storage account, whatever. Then they have, for example, a platform or infrastructure team with different resources, for example, like virtual network, subnet, virtual machines, firewalls, and so on. And they sometimes have business systems teams, which in this example, they're going to have a web application with this kind of resources like SQL database and so on, and also a CRM team, which is creating or managing a CRM platform. And all these teams, that is quite often the case, are using or working isolated in different silos. So there's no synergy between the teams. There's no collaboration or interaction between the teams. They're all working in their own, more or less, in their own world, but they are not thinking of, hey, how we can actually collaborate. But if you have a look at the resources, they all, for example, need a resource group, or they all need a storage account, or virtual machines, or if you see any other resources. That's also why the case why it makes sense to say, hey, probably we should think, it makes sense to provide something centrally, yeah? And this central aspect can be, for example, the central library principle. So what it makes sense, instead of each department is programming their own, in this example, storage account or virtual network, we're going to provide a module in a central module library, which can be consumed. Yeah. And for example, the platform team is taking the ownership of these modules and make sure, okay, the life cycle is managed accordingly. Yeah. So for example, if there are updates or if there are attributes are deprecated, the platform team is managing the modules and making sure that the modules are always up to date, yeah, for the latest version. And then we have, for example, the infrastructure team, and the infrastructure team can access or use these modules to create their resources in this kind of infrastructure template repository. Or the CRM team can, for example, use the virtual machine API or any others. Yeah. And also we have a business systems team, which can also use, for example, storage account, API management, or any other modules in this example. Yeah. So now we have more or less this central module library aspects, and these modules will be placed in a Terraform registry. We also have a look at that later, what a Terraform registry is and how it behaves and how we can actually we can actually manage it. So now we talked a lot about modules, what is a module, but now we want to have a look at a real module, how it going to looks like in the code. As you see, I have plenty of modules here. Yeah, I have modules for Postgres Flexible. I have modules for virtual network, for virtual desktop session hosts, whatever. But the structure, as you see it here, is always the same. Yeah. And each of these several folders is a separate repository. In my opinion, in my case, I have it on GitHub. So what I first normally use if I have a look on a module is the examples. Each module must have at least one working example. This is normally where I look, okay, what kind of resource attributes do I have to define or to consume the module in a proper way? So in this case, I can create a resource group with this name. Then I'm going to create a virtual network with this address space and so on. Yeah. So I can see here all the parameters I'm going to need to define my resources and my cloud environment. And I can more or less read this like a book. So if someone asks me, how is my virtual network configured within the organization, more or less I can give them this TF-var file and say, hey, this is how my environment is configured. And this is the only thing I have to do more or less is to copy and paste this TF-var file and adjust the parameters so it more or less fits to my environment or to my purposes. And that's more or less all. Yeah. So I like to have a look at examples because then I can see how I can actually consume this module. The second place where I need to look at is more or less the main file. And then the main file defines, okay, which kind of resources are currently created. And this is, for example, the resource group, then a virtual network. Then I can also see, oh, I can create several subnets. I'm not limited with this to one subnet. I can create with the for each loop 20, 200, 2000 subnets with one call of the module. NSGs, network security rules, and so on. What I like is if I program modules, I want to, with certain kind of resources, I want to have them feature complete. That means more or less all of the attributes are there, and it covers more or less also most of the use cases for different teams within the organization. For example, I don't want to force teams to create a resource group, but also I can say, okay, create resource group false. Then I can also use an existing or already existing resource group and create a virtual network then inside the already existing resource group. It's totally doable. Yeah. Then we talked about we have inputs. So inputs for the modules are always with variables underscore. So I can see, okay, for virtual network, I need to define certain kind of attributes, but I also have default values. Yeah. The good thing with default values, if I do not define anything, the default value will be used. Yeah. In this case, it's false, but I can override the default value anytime. Yeah. So I will have a look, or I can also have a look at different variable files. And also if I create a module, something will coming back. So for example, I want to see, okay, what is the virtual network ID, or what is the created virtual network name, or what kind of subnets are created when I call a module. So, and the good thing is also if I have main outputs and df and also the executable example, I can deploy, for example, in this case, the virtual net or this example. So this example must be executable within itself. So then I can also have a look, okay, that I make sure before I consume the module, I will understand how the module works. Yeah, that's super important. Then we also have things like, for example, a README file is super helpful. That is, okay, what is the module actually about? This is about creating virtual network, including all configured subnets and other things as well, and association to the subnet. We have a licensing file, which is not mandatory, but we have a Terraform linting file. We come to that later. I like to lint my code before I put it in or push it into the repository. Because I make sure, okay, it's configured the right way. We don't have, for example, unused variables and so on. We have a git ignore file, which is also needed because if we test something, sometimes the .tfvars folder will be also pushed to the GitHub, which is not really my intention, for example. And we have editor config, which is the standard. So as you see, it doesn't matter if I have a virtual network or, for example, a Postgres flexible. The structure is always the same. Yeah, we have, for example, the main file, we have variables files, we have output files, and we have at least one working example. In this case, we even have 3 working examples, and this is always the same structure. Yeah. So this is what a module always looks like. And we also Terraform describes what kind of files and also what kind of folders are supported within a module. And I would say, stick to the standard which HashiCorp Terraform describes. I wouldn't, in this case, I wouldn't do my own thing. Yeah, so that's super important. What I also have here, I described it, what we just had, or we just described is, it's written here down in a form. There's also some examples for the Git, for the editor config or for the git ignore, which are best practices. It's also here with a link, you can use it. I will upload the slides anyways after the session. Yeah. So the file and directory layout is pretty much standardized, right? So it's really nothing special. Yeah. It's also recommended to use a template. For example, if you create later on in the project, sometimes you have up to 40, 50 or 60 modules, and it makes sense that all the modules look pretty much the same and having the same standard. If you have new modules, also create your repository from a template. Yeah, that's what is really recommended. So the standard module architecture is more or less what we had. The repository and module is one-by-one relationship. In this example we just had in the code, I can say, okay, I don't have to create a resource group, or I don't have to create a virtual network, but I can create one if I need it. Or I can also create a virtual network if I need it. I also can create if I create one virtual network, I can also create several subnets. So that's the reason why we use for each loops. And what we have to think about is, okay, if we talk about a module with virtual network, what characterizes a virtual network? I mean, as you see, I have plenty of resources. We can also think, okay, does it make sense to put a virtual machine in here, which we probably need for the project? Probably not. We can also put it into a separate module. Like, for example, we have a virtual network gateway module, which characterizes a virtual network gateway like a VPN connection or express route. Or what characterizes a load balancer or a virtual machine. Yeah. So for virtual machines, for example, I wouldn't put it into my virtual network. I would rather use a separate repository to create a virtual machine with all these dependency like disk, NICs, and yeah, encryption, disk encryption sets, and so on. Yeah. So it's always a one-on-one relationship, and then we have to think, okay, what kind of resources we want to create within the module. So as I said, what we have to ask ourselves, what characterizes a virtual network, or what characterizes a storage account or virtual machine? So it's making sense to say, okay, how should the module look like so it can be used by several organizations on business units or departments? Yeah, so it's not only limited to one project. If a module, for example, is hard coded and it can only be used once, then we don't need a module. It's totally useless because reusability is a central aspect if you want to create a module, for example. Yeah. And then one more thing, which also had in my previous company, once my boss came and say, hey, writing modules is a super easy, dull, and repetitive task. So let the trainees do the job. Yeah. And I was fighting with him and said, no, it's not dull and repetitive and also not easy. I said, hey, there's a lot of things that could go wrong. And I called it the triple knowledge gap. Because you have to understand, if you want to program good modules, you have to understand three things. First of all, you have to understand how the Terraform provider works. In this case, for example, the Terraform provider for Azure RM or for Azure AD, whatever, or AWS, doesn't matter. Yeah, so you need to know, okay, what kind of attributes do I have? What kind of resources? Are there any dependencies? And how version updates work. For example, the Azure M provider is updated each Friday and a new version will come out. You have to think about, okay, how going to handle these updates? What is the resource behavior on this cloud platform and how the cloud platform itself works. So you have also limits and quotas, for example, on Azure, which you have to understand. You also have to have in the dependencies. That means, for example, you first need to have a resource group before you can create actually a virtual network or a subnet. And are there any policies in place on your tenant which probably could limit your resource creation? Yeah, that also is also the case. And then we have to think about, okay, how to design, or if you understand both the resource provider and Azure RM and how how Azure works, then we can also think about, okay, how are we going to produce reusable modules and make sure that the structure is right, that we follow best practices, and then that we don't produce breaking changes. And at the end, all the departments, for example, will have issues if we, for example, have a breaking change. And also how we're going to do the life cycle handling. So these three fields we have to bring together. And that's also the reason why it's not really an easy and dull repetitive task doing programming modules. You have to think about, okay, all of these, I would say, three domains to bring them together and program then really then the good modules which are reusable. Yeah. There are already Azure modules, for example, out there. You can use the Azure Verified modules, AVM, as a starting point. So if you say, hey, we are under pressure in the project and we are allowed to use open source modules, then this also could be a point. I put the link in here. So you can also use these Azure Verified modules. These ones are verified by Microsoft. And because I think the ACTF mod, it was called, is meanwhile deprecated. So the Azure Verified modules are then recommended if you say, I don't want to start from scratch with modules, or module programming. So what are the do's and don'ts regarding modules? Yeah, I've seen over the last few years a lot of weird things in module programming. And I thought, okay, it probably makes sense to do some screenshots and put all the things together, what we should do and what we shouldn't do regarding and follow certain kind of principles regarding module programming. So how are we going to distinguish bad modules from good modules? Few weeks ago, my colleague said, he had to use a module from someone else, and the module was really a nightmare. And bad modules, they can really drive you nuts. It's not fun at all to use it, and it's also leading to bad results and sometimes to unexpected behavior. If they're not programmed the right way. And and we also have the comparison to good modules are fun to use, so it's easy to use, fun to use. You have good results, and they are easy to maintain and also easy to manage. And but what are good modules and what are bad modules in details? I also wrote an article about it. I put the link right here. I'm going to upload you the slides so you can feel free to use it and ask me questions if you have some. No problem at all. So the first principle is follow the KISS principle. I've quite often seen that we have big monster repositories. I really call them monster repositories because we have, for example, plenty of modules within one repository. And we, as I already said, normally we have a one-by-one relationship. So one repository is one module. And often an example is missing. As we see here, there's no example. If I have a module for Terraform Azure RAM policies, I don't know how to use it because there's no example. It's not there. Sometimes it's unstructured, hard to use, and we have endless variables. So I don't know what the difference is between these variables and what is in here, because it's not really following any naming convention or so. So what our good practice is follow this. So each module is a separate repository, as I already said, and we have this defined file and folder layout. So we have a working example, which is executable and testable. We have certain kind of input variables with a proper naming convention, as we see here in the green box. And also we have a certain kind of output variables, also with a certain kind of naming convention. So everything is more or less keep your module small and self-contained. A module is serving a specific purpose. So what is also recommended, if your module is called virtual network, don't put any other things in this module, like, for example, IoT hub creation or a storage account or database creation. That would be a separate module. So, and that's also why we say, okay, we want to create or keep our modules small and self-contained. A module must be independently testable with this example folder. So don't use any or do any dependencies to other modules, because then you can end up in a dependency mess. And if your module is doing too much and it's getting bigger and bigger, think about, okay, probably it makes sense to break the module into smaller pieces and create more specialized modules instead of one big module. So we should keep it really short and simple, this kind of the modules, instead of creating big monster modules. We should have a repo and content structure. As you see here, we have plenty of modules. it's not following any naming conventions. So for example, this one is more or less a camel riding case. Then we have dashes. We have unformatted code, which is hard to read, sometimes with empty lines. I don't know what these TF-var files are good for, only hub, only spoke. And then we have output as singular, which is really, it looks really messy. Yeah. So the good thing would be, like I put the link in here. How does a standard module structure look like? We just talked about it the previous slides before. We use predefined repo template, which is highly recommended. And please check if all your files and folders are correct. That we have also an example that the tflint file is in each repository, and it's that the things also the code can be validated before we're going to merge it into the main branch. Yeah. So avoid nested modules due to complexity. Yeah, because then we have modules and modules and so on, which is really stressing you out. Even if you see, please also validate your the naming or the prefixes of your TF-var files. Yeah, especially if you use your CI/CD pipeline and say, hey, the merge request will be rejected because, for example, the output is here, the S is missing. Yeah. And then every module is more or less looking like pretty much the same, yeah, regarding the structure. Before you start programming modules, think about a proper naming convention. Yeah, I've seen so many guys that said, "Hey, yeah, we don't need a naming convention. Each developer is programming their own modules in their own way." I'm not a big fan of it. I hate it, to be honest. Yeah. Because then we have something like in the screenshot, sometimes they use dashes, we have different prefix, sometimes they hard code things like here. All of a sudden there are data sources in my main file, what the heck they are doing here. Is this really needed? And here we have underscores, yeah? So better would be, okay, we define from the start, before we start, we define a naming convention. For example, Julian and I, we always have naming conventions. So that means, honestly, I don't see if Julian or I did the module because we program it pretty much the same way and it looks also the same. So we have a nice standard and the customers like it because then you can also, it's easier to read and it's easier to troubleshoot if you need it. Yeah. And if you define a standard, stick to it. Don't throw it overboard after 10 or 20 modules. Doesn't make sense. Lint your code. Make sure that it also have the right prefixes, that you have the right resource identifier, that you strive for consistent and descriptive names. Yeah, that you can actually read the code easily. Yeah. Weird abbreviations which are difficult to read doesn't help anyone. Yeah, so that's the reason why I say, okay, a proper naming convention is essential for good and nice modules.
Stefan,
yeah,
just a short comment when you go back one slide. Yeah. So I think you probably will have a slide, but you just mentioned it. So this is about naming convention. So what's really, really important when you start, or maybe you are already on your journey, of course, you need naming conventions, but you should have a style guide in total, which describes how your Terraform modules should look like. So naming convention is just one part, but especially like how you use, when you're allowed to use count, for each, and so on. But I'm sure you will cover this later.
Yeah, that's good to mention. Yes, you see here an example, what Julian mentioned, we have count, which brings more flexibility, and also we have for each. Yeah. So sometimes it makes sense to loop resources because then if you don't do that, you're limited to create one subnet. But probably I have to create 2 or 20 or 200 subnets. That's the reason why I use for each loops. That brings more or less the flexibility. And that's also what Julian mentioned, which also helps to make modules actually reusable for different use cases. Yeah, I'm also almost feeling a little bit embarrassed that I have a slide which is called "Do Not Hard Code," but I've seen it so often that modules are hard coded, which limits also your flexibility. And then if, for example, here in this case, the virtual network gateway will always create a VPN gateway, route-based. But what is if the case, for example, one team needs an express route gateway instead of a VPN gateway, and then if it's hard-coded, you cannot change it. Or you have fixed naming patterns. If you have fixed naming patterns, you also can program or create a naming module, which will use these kind of parameters as inputs and then give you a name back as an output, and then this name is then standardized. So we have a lot of hard-coded values in here, which is really not recommended. The best practice is I like to use default values because default values are overridable. So if you don't like to create as a standard a VPN connection and you want to create an express route, you can say, okay, the virtual network gateway type, I can also use express route, and this value will be overwritten. Pretty easy. So we have more flexibility if you use default values because these ones are overridable. Don't do something like that. Even not if you say, hey, I never use something else, but I mean, if shit hits the fan, then you have to touch the module again and have to replace, for example, this VPN string here through a variable. I mean, it's doable afterwards. No, it's not a problem, but I like to have my stuff feature complete and using default values as best practice. Keep your modules dry, so don't repeat yourself. Sometimes I see things like that they say, okay, I create a random password for data center and create a password, pretty much the same values again. So that means also that you will blow up your code. You have more lines of code. You have duplications in it. It's hard to troubleshoot. The maintenance effort is higher. I don't like to use something like this. Instead of copying the code, like in this case, I like to have for each. That's also what Julian said. For example, if I need multiple public IPs in this case, I use for each loops because then it doesn't matter if I create 500 or 50. I just use the for each loop and I iterate through it and create the number of the number of public IPs I need more or less. Which brings also more flexibility. There's also a good article where there's a difference between for each account. There's a good article which described exactly the difference. So I highly recommend have a look at what the difference is and what it brings, especially if you change resources and you use count, you can run into trouble because of this, I would say, key aspect. I don't go any further detail with count or for each loops because then we gonna expand the time more or less. So these are the best practices, but now we have to understand, okay, what is the module? What are the best practices? How are we going to program it so that it makes sense? What are the do's and doesn't? And now we have our modules and we have to publish it somehow. And how are we gonna do? Okay, we have to publish and version the modules accordingly. And this normally will be done by a Terraform registry. So what is a Terraform registry? For example, Terraform Cloud helps to provision infrastructure, and it also provides a Terraform registry, for example, a private or public one, where you can publish your modules. I will show you this in the next demo, how we're going to publish it. And also it supports versioning for providers and also the modules. So if, for example, you have modules for AWS or you have modules for Azure or for Azure AD, whatever, you can also pin a certain kind of version, which is important for breaking changes. The good thing with a registry is also we don't have to give our consumers directly access to our repositories. So more or less the Terraform registry is a layer in between our consumers and our repositories on, for example, GitHub or GitLab or whatever. So we can also hand over give them tokens so they can access actually the library. but also can set several kind of permissions instead of giving them directly access to our repository in our versioning control. Yeah. We have two kinds of registries. There is a public registry under registry.terraform.io, but more important for organizations is the private registry, where we will have a look at the, I think, the very next slide. Yeah. Yes. So how does the Terraform registry look like? As I said already, I can put it in here. We make it a little bit bigger. For example, we are here in the Terraform cloud, and imagine we are an organization called PrettyX, and this PrettyX is having a registry, a Terraform registry. And as I said in the code before, we have also virtual network. Yeah, we have different kind of modules. As you see, I have firewall policy modules, I have module for IP group, for key vaults, and so on. But we can also have a look at our virtual network module, which we had a look shortly. So we have here our virtual network module. And you see, okay, this module is published in the PrettyX organization. It's an Azure RM provider module. And also you see here, this module supports different versions. For example, on the next Friday, I think it's the 1st of August, a new Terraform provider will come up, probably with some changes in the virtual network as well. And then we can theoretically provide a 1.58 version. Yeah. So that is also the reason why it is super important to have tags on our on the repository. And you also see this module in this registry or private library is linked to my GitHub account. So if I click here, I'm gonna end up in my GitHub account, and you see this is more or less the module which I had here in my Visual Studio with this certain kind of files. And I put also tags on my repository, and these tags automatically will show up in the Terraform registry as different versions. So we can, if we consume the module, then we can pin our the module to a certain kind of version, which also means if I have breaking changes in this module, the teams which are using the older versions are not affected at all. Yeah. Then we see the module we have the README, which is also part of the repository. I mean, it's this README is a little bit poor, I know, but you see how it works. That's pretty straightforward. Then you have the input variables with required inputs and optional inputs. Yeah, so that means what is really required in this module with all the descriptions, so you can read through it. You also can browse to the default example, for example, and you also see what is, if I create a module or if I use the example, what will come back. Yeah, for example, in the Terraform TFRs, when we execute it or the module, you see these values are coming back. So I can exactly see, okay, this is the name of my resource group. Oh, look, I created some subnets, virtual networks, and so on. So these values are coming back from the module if I consume it. Then we have the dependencies. I'm not a big fan of dependencies to other modules. That's the reason why I always say, okay, a module must be independently testable. And you also see on the resource overview, what kind of resources in the overview, what kind of resources can I create using this module? Yeah. For example, this more or less covers all my, I would say, demands regarding a virtual network. So I also not only can create a virtual network, I also can create subnets, I create route tables, and so on. So you can see in this registry all the modules and how you can use it. There's also on the right side, there's an example how you can consume the module. So you can more or less copy and paste this kind of piece of code and insert your variable inputs then here. Yeah. So for example, if I say I want to create this app Terraform IO customer PrettyX, that's the organization, and then the Xspirit Azure RM virtual network, I will create a virtual network and also can create with the 1.5.7. Yeah, this is this kind of versioning which is here, but you also can create using 1.5.5 instead. Then you are using an older version of this module. It's not a problem at all. Yeah, so it's really not magic. This kind of library. So more or less, what you do, you use your Terraform registry and connect it with your in this case GitHub with all the repositories. And then you have a module registry with a lot of modules which you can provide to other teams or business units within your organization. Yeah. So this is this aspect of Terraform registry. Highly recommended is to use semantic versioning for tagging of the modules. So for example, I always use tags. Yes, and you can also see also the history of different versions of your module. For example, if I have a team which is an Azure landing zone or platform team consuming several kind of modules, and also, for example, you have application teams like web application, CRM, whatever, they also use, for example, different modules. And as you see here, the Azure landing zone team is using the 1.2.0 version, and the application team is using a newer version, 1.2.6. Yeah, so it is totally doable if you use semantic versioning, that you reference to different, I would say, versions of modules without any issues. So that's also the reason why it's highly recommended to use tags on your repositories. Yeah. There's also certain kind of structure. I don't want to go into details. I wrote a lot of blog stuff on my page. Why it makes sense to structure your repository like this. But regarding the modules and the central module library, you're totally flexible if you set it up like this. So how to use modules in templates? Yeah. So how to consume it. I mean, what I often said is, okay, local path, I would say forget about it. Don't do it, because quite often you have to copy code. It's not really recommended at all. You can also access directly the repository. Instead of using Terraform Registry, you can directly access the GitHub repo instead of using the Terraform Registry. But I like to use either private registries or public registries with semantic versioning. So what you do, okay, you say, this is then the URL which I can use to access the module, and then I can say, okay, which kind of version do I want? Yeah, for example, if next week is coming a version 4.1.0, I just have to adjust this kind of version, and that's more or less all I have to do, and then I use the updated module. Yeah, so more or less the consumer can decide when to use an upgraded module, or if I use more or less the old one. This is not recommended. It's still on the slide, but I don't like this kind of type of versioning. I always use semantic versioning, which is way easier. Yeah. So we have modules, and we have also the modules now in our registry, which can be consumed. But we also say it makes sense, okay, what kind of additional tooling can be used to improve our quality of modules? For example, what I like is the Terraform linter. Yeah, so I can lint my Terraform code. For example, if I have deprecated modules in it, deprecated attributes, sorry, or if I have some other issues. So the linter is makes life easier, and also supports certain kind of detects potential issues, also complaining about best practice violations, or if you're using deprecated attributes, for example. So this, I also put the link in here. So the Terraform linter, you can also put it into your CI/CD pipeline. So if you're doing changes and push it into your repo, say, hey, this is not is violating our best practices. So the linter will complain. You can also use other tools like CheckOV. I also put the link in here, which is used, or Sneak or Trevi. And these tools are used for static code analysis. For example, for security or compliance issues. For example, you create a key vault which is exposed to public internet, or you create a storage account which is exposed to public internet, or you create a virtual machine with a public IP and a network interface card will also complain. Yeah. So this is more or less doing static code analysis and analyzing your modules and your examples if it makes sense, and if you violated any best practice. Sometimes even it's nice that if you program a module, for example, and if you got to delete an unused or variable, it will complain that you have variables which are not used in the main file. And then and it said, hey, please fix it before you push it into your main file or in the main branch. And that's also nice that you have, said sometimes you forget things, yeah, and tools like that, they support to make sure that you have a nice quality of your modules. Terraform docs is really great. It's a tool which creates automatically your README file from input and output definitions. With Terraform test, you have it's written in Go, or you have to write it in Go, which is a framework for writing automated tests. Honestly, I never used it that much. Yeah, it's what we more use is pre-configurations and so on to make sure, okay, we have unit tests in place for certain kind of modules. And also you have TF update, which automates your version updates. Can be used also in the pipeline. So these are, I would say, there are also other tools like infra costs, which also can say making the difference if you make changes and figure out what are the costs and the difference. There are plenty of tools out there. I mean, you have to figure out, start with the easy one with Terraform Lint or Terraform Lint and probably check OV and Terraform docs, and then you can also put in your CI/CD type pipeline using other tools as well to improve the quality or support the quality of your modules. So last but not least, the essentials or key takeaways of all the information. So what is really important is start with modularization from the beginning. Yeah, don't say we will do it later, because the technical depth will increase. I've seen also customers which started with shitty modules and say, we will professionalize it later. I wouldn't do that, because it costs you a shit ton of time and you have to import then all your created environments and cloud resources then into a Terraform state file, which is a nightmare. I wouldn't do it. So start right from the beginning, which makes the life way easier. Keep your modules flexible. Do not hard code. Work with count or for each loops, which brings also additional flexibility. And follow this code best practice I just showed you. Also, HashiCorp Terraform in their docs, they're writing how a module should look like and why it should look like exactly like this. Don't do something special. I'm not a big fan of it, because sticks close to the standard as possible. Make sure all modules look the same. That's this aspect of standardization. As I said, we only start programming modules if we have a certain kind of, for example, naming convention, standard, structure. So we make sure, okay, we follow a certain kind of look or standardization for all the modules. Use a central module library across projects and departments. It doesn't make sense if you have a central module library, for example, for each project, because then, for example, quite often you have only you have modules, but you only use it once. That doesn't make sense. If you want to use synergies between your departments or projects, a central module library can make sense, and also the platform team then is making can put all the effort in to make sure that the versioning of the modules is managed according to the life cycle of the provider, which makes totally sense. Version your modules using tags to make sure that you do not implement breaking changes and all of a sudden the other departments or projects code is not running anymore. This is really not recommended. And use proper tools to improve your code quality. As I said, there's a lot of tools out there which can be used for improve code quality automatically or support you to improve your code quality. because quite often we know day-to-day business can be stressful, and sometimes you forget things or violate things, and so tools can help to improve your quality. Yeah, that's more or less it. Last but not least, quick words about myself. Yeah, I'm a cloud solution architect at Xebia. I'm a Microsoft MVP for Azure Infrastructure as Code and also Azure Networking. Please, if you have questions also to the presentation, which I will upload to my GitHub account here, feel free to download it, to use it. If you have questions, do not hesitate to ask questions if you have. So let me know. And if I don't know the answer right away, I also have other experts within the company which can answer the question. So let us know. Feel free to reach out, and I'm willing to help. Yeah, that's more or less all. So if you have questions, let me know. Now we can do a Q&A session, or just hanging around having some whatever beers, or yeah, let me know what you're thinking about all these kind of details, or if you have questions, let me know. There's something on the chat.
Yeah, we had one question, but I replied to Shishir.
Oh.
I hope I spelled the name right.
Anton, the question, what we usually explain during our IaC community presentation is okay. Products, language, justified. Well, yeah, that's also a nice advantage of Terraform. You can even write your own provider. You're not limited to Azure, AWS, or Google. If you can program your own provider in Go, written in Go, and certainly use it. If you use, for example, Bicep, you're more or less limited to Azure, for example. That's the reason why also, or the main reason why I'm a big fan of Terraform. Like, for example, we also had used providers for info blocks, for example, which was really nice. With Bicep, you cannot do that. Yeah.
In my opinion,
Other
the
questions?
only good thing about Bicep is that you don't need to handle the state management, but
yes. Yeah. But
well,
with
that's also
Terraform Cloud,
not really a big thing. So when you're using Terraform Cloud, it's really nothing. And even if you don't have Terraform Cloud, so as soon you have secured all your storage accounts, it's not a huge pain.
That's right. Yeah, correct. Yeah, that's the reason why I like Terraform more or less than most. Yeah, because it's you can provision manage your resources cross-platform. It's not only limited to Azure. Yeah. Any other questions? Not yet. So if a question comes into your mind, yeah, let me know. There are my contact details. I'm willing to help. And yeah, hope this helped. Yeah.
Oh, we have a question from Anton. Stefan, you can go.
Yeah. What about passwords static in a var file? Yeah, that's a good question. Passwords in var files, or passwords in general, or tier var files, is really not recommended. Normally, for example, if you need a password, for example, imagine you create a virtual machine and you need a password for the local administrator. I like to use the random password resource, like we had. Scroll up real quick. Like we had here, there's a resource called random password, and I placed the random password in, for example, in Azure Key Vault as a secret, and then use this secret as for the local administrator as well. Yeah. The state file is also what Julian mentioned. The state file in Terraform is super important and must be protected, because sometimes there can be critical or certain kind of secrets or sensitive values in it. So that's the reason why I say, okay, don't put your password into the TFR file or the secrets. It's really not recommended.
And
Yeah,
one thing to add, so if you use like the random password resource, what you can do, since some versions you have ephemeral resources in Terraform, so you will not have the value in your state. So
state file, yeah, ephemeral resources, yeah. That's, I think it was a few weeks ago, I think. It was not that long ago, right?
maybe
Ephemeral resources.
maybe 2 months time is really
Yeah, yeah.
ready for a summer vacation.
Yeah.
So maybe a question for the attendees, So if someone is already using Terraform, are you using it for Azure, AWS, GCP, or maybe even for on-prem providers or use cases? Can put it in the chat if you want. You don't need to mute yourself. Totally fine. AWS.
AWS, yeah.
Okay, also some on-prem stuff. Yeah, I was
And
starting
AWS
with VMware on my Terraform journey already some years ago now. But as Anton said, so it's always same language. The provider takes care for translating to the upstream API.
Usually we all use Azure. Yeah, that's right. Yeah. It's coming in this case. And how familiar to the audience? How familiar are you with Terraform Cloud? Who's using Terraform Cloud? Or are you managing the state file, for example, with a storage account or something else?
Or maybe even Terraform workspaces via command line.
You can also put it into chat if you want. Okay, no reply. All right. Are there any further questions? Either unmute your mic or put it into a chat. Because then otherwise I would stop the recording, I would say. 3, 2, 1. Stop the recording. Okay, stop it. Yes.